Okay, guys, today we'll be dealing with trig functions. Trig functions in general is quite easy. We can deal with it. And I think that even in grade 10 and 11, it's simple to deal with. So we're going to start with the most basic trig function, y equals to sine, and we're starting with the sine graph first, right? Y equals to sine theta. Now, guys, I'm going to put a restriction in this of theta is an element of 0 to 360, right? I'm going to put that as a restriction, and we're going to draw it because it's quite simple. So my rules for trig functions would be to step in 30s for sine and cos. Teachers can step in 45s if they want to, but generally it's up to you to decide. Because if they give you a graph, and if it's stepping in 45s, then you follow along. If they give you a graph and the graph paper has 30s, you follow along. I prefer 30 because the graph's more accurate. But if your teachers give you something and it is stepping in not 30s, if it's stepping in 45s, then we go with it. Now there's rules. There's rules to it, and we need to figure out how to deal with each part, right? So I'm gonna try my best to get this to be accurate, but please understand that I'm drawing on a graphic tablet, and things like this is not very easy to draw. If I had pen and paper, it would be fine, but that's 30, 60, 90. We'll put this as 120. This as 150, 180, 210, 240, 270, 300, 330. Now, most of the time, they won't make you draw a graph. They'll make you answer it. But if you understand where the graph is coming from and you understand how to draw it, then the rest of it is generally just simple. But let's go with 1, 2, 3. That's -1 and -2. I guess this minus is more of a direction. So this Cartesian plane that we have is starting at 0 and going to 360. Why? Because that's where my restriction is. If it was minus, we could have started at -180 and go to 180. But let's start with all of the important parts of, let's start about all the important parts of the sine graph, okay? We're going to start off with how to draw a basic sine. So rules for a basic sine graph is to go to your calculator, and we're going to start off with, let's put the rules somewhere there. Let's put the graph a little bit more down. Okay, cool. Let's go with the rules to draw a sine graph, guys. Rule 1 is to press mode in your calculator. Right, we're gonna press mode. Thereafter, we're gonna press table. I don't know what value table is on your calculator. On mine, it's 7. We're gonna end up with f of x. Now, with f of x, I want you to put sine, open bracket, the big X that's above the bracket sign. You're gonna press alpha and X and close the bracket. So sine, there's a big X, you press alpha and you press the X button and you close the bracket. Then we're going to press equal. Now, guys, you're going to end up with g of x. When you end up with g of x, please understand that we can draw two sine graphs at once. And for grade 11 and 12, you do need it. But for now, let's skip it. The next one is we're going to start. We're going to start at 0 because we're starting at 0. We're going to end at 360. And for my graph, we're going to step in 30th. So we're going to step in 30th. Right? So again, we're going to put sine. It's going to be x. Start at 0, end at 360, step in 30th. And the graph would be generally quite simple. 0 is 0. 30 is 0.5. 60 is 0.86. 90 should be 1. Okay? 90 would be 1. 120, it would continue on this part. Later on, you'd understand why. I'll show you guys that each part has its own, it matches on both sides, but that's 0.5, 0.86, 270 is there, 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 there. Okay, now if we draw this graph, I'm going to try my best to draw it, but let's go to that part there. Okay, now this is more of a grade 10 level graph. I know this point doesn't fit perfectly, but that's all I can do. So let's start with some words that we need to deal with when it comes to a basic graph, right? For a basic graph, the period is for sine, the period is 360. Now, the period means how long does it take the graph to completely start and end? So a sine graph looks like that. So how long does it take for that to go? 360 degrees. The domain is all the possible x values that are in this graph. And the domain starts at 0 and ends at 360. That's all there is for this. The range is all of the possible y values that we can have. And the possible y values would be the lowest value, -1, which is starting, to the highest value, 1. Okay? So this is the information that we got, the basic information. Let's go with some of the other information. Let's start with the x-intercepts. So the x-intercept would be 0 and 0, 180 and 0, and 360 and 0. This is all the parts that are touching the x line. Okay? So there's it here. It touches the x line at this point, and this point. If we go with the y-intercept, the y-intercept will be the part that's touching the y line, which is 0 and 0. Okay? Now, guys, there's some other words that I'd like you guys to learn. But before we learn about that, let's talk about the maximum turning point. So the maximum turning point should be 90 and 1 because that's where the biggest turning point is. And the minimum turning point should be 270 and -1, right? We also need to learn a part called amplitude. So for y equals 2 sine theta, for the amplitude, we use this value in the front. It is normally an a value, but the word amplitude is, it falls in this range of stuff that you really need to know. You can't just always look at the graph. For the amplitude, it is the maximum height above the x-axis or the minimum height above the x-axis, but it does change. But the best way to do the amplitude is either look at the formula, look at the value in front of a, or take the maximum point plus the minimum point and divide by 2. And you don't need to include the minus parts like the -1 and +1. Let's look at this. The max is 1 above the x. The max is 1 below the x. So 1 plus 1 divided by 2 equals to 1. And it does make sense because this part that's here, this is the amplitude. This is the amplitude, but it's not always divided by the x line. It's sometimes the graph is shifted up and down, so this would be the max part that there is. Right, the next part that we deal with is the proper formula that you will see. So y equals to a multiplied by sine theta plus q. Okay, so this is more grade 10 level. It's quite simple to deal with, but we need to understand each part of the formula. This A and Q is debatable what letter it is. It can change. But this A stands for amplitude. This is the height of the graph. And this Q is the shift. Now, it is the up and down shift, right? So please understand it's the vertical shift. It's the up and down shift. If it's +5, it moves up 5 units. If it's -5, it moves down 5 units. So it's just the vertical shift. Let's go and explain it properly. Let's start with Q since it's easy. If Q is +5, it's going to move up 5 units, right? If Q is -2, it's going to move down 2 units. So that's all there is to it. But now the effect of A is where things tend to change quite a bit. A is a bit difficult to deal with, so let's start with it. Once you understand that A is broken up into 2 parts. So A is broken up into whether it's a positive number or whether it's a negative number, right? So if A is positive, as A gets bigger than 1, the amplitude is going to increase. Okay? So the amplitude is going to increase. And what do I mean? Firstly, maybe the graph looks like that. But as A goes to 2, graph's going to look like that. As A does not go -1, but as A is less than 1 but greater than 0. So basically it's a fraction that's in between 1 and 0. The amplitude decreases. Like if A is half, then maybe the amplitude was looking like this. Now it's going to look like that. It's going to get smaller. So the amplitude gets smaller. But that's fine on the first part, right? The next one is what happens when A is negative. So when A is negative, please understand that this is a reflection. Okay? This is a reflection. What do I mean by reflection? I mean that A used to be like this. Now the graph is like that. It's flipped around. You can see it was a sad face. Now it's a happy face. Like some of my students. I'm not going to mention names. But let's go with like this. Now this is when A is negative. It's a reflection. So if A is less than -1, basically we're talking about this. It ties up together. -2, -3, -4. A is getting bigger on the negative axis. Then what's going to happen is this is a reflection, of course. It was like that. But now it's going to get bigger because it's the same as the A greater than 1. And the same thing is when A is greater than -1 but less than 0. So basically it's like a negative fraction. This one and this one tie up together. So A was like that. Now it's going to get smaller. So the amplitude increases. And the amplitude decreases. Okay, so we can see that this part might be complicated at the start. But as long as you tie them up together, if A is greater than 1, it's going to increase. Or if A is less than 1, it's going to increase. Because less than -1. Because you can see that we're talking about 2 parts of the Cartesian plane. It's either going to increase on the positive axis. It's either going to increase on the negative axis. So those two go in line. But if A is ever a fraction, not any fraction, but a fraction between 0 and 1, something like half, 1/3, 2/3, A is going to decrease. It's going to get smaller because now it's not even 1 full amplitude. It's less than that. So it's for us to decide how to deal with it. But that's the first part that we deal with, right? The second part is I do have a picture that I'm taking from a textbook that you guys can use to learn and draw in your book. So we can put that here. And this is just the textbook, guys. There's a basic sine graph. A equals to 1 would be the basic sine graph, which is there. So everything else compares to this basic sine graph. You can go and look at what happens. Where was a equals to, well, no, that's not a equals to 1. A equals to 1 is here. Okay. And then you guys can go and compare this to all the other sine graphs here and just see what the graph would look like when it increases. Let's look at this. A is bigger than 1. I can see that the amplitude is increasing. There. A is less than 1. We can see that it's decreasing. Let's try and actually use, let's try and use green just to make you understand. We can see this, but then I think this messes up the graph. Okay. I think this messes up the graph, guys. This green, I'll put a mark there. That's the green graph. That's the green graph. The next one, this is the pink graph, and that's the pink graph. This is the orange graph. That's the orange graph. And the last color, just to let you know, I know there's a scale. I know there's a scale there, and it's easy to see, but if you guys didn't understand, that's how we tie everything together, okay? Now, the effects of Q. Q is quite simple. Q is literally just moving the graph up and down. Whether it's 5 units up, whether it's 3 units down, whether it's 2 units up, it doesn't matter. The graph will be moving up and down. So that would be the shift up and down. Quite simple to deal with. There's a lot of parts where we struggle to understand, but now we're gonna draw a different type of graph. We're gonna try and draw, let's try and draw a graph y equals to 2 sine theta plus 3. Let's put it as element x is an element of 0 and 360, right? And let's compare it. So this graph goes, oh, I just messed up. I had such a nice graph prepared. Let's leave that graph there. Let's copy it. Okay, so now we have this here. Yeah, cool. Let's go. Let's add a little bit. We're a little bit short for this graph. Okay, so I'm gonna leave this old sine graph there just so you can see what happens. I'm gonna add a little bit more to this graph. And if you want, I can remove 3, 4, 5. I can go and remove the sine graph if you want, but this is the basic sine graph, right? This is y equals to sine theta, if you guys want me to do that. But let's go with this question. I would press mode. I would press table. This is the part that catches you guys. When it comes to f of x, do this here. Put 2, put sine, put open bracket, put x, close the bracket, and then plus 3. Guys, your work with me to help me. That's sine. So we're going to go with 2, sine. That's x, close bracket, plus 3. G of x. We're going to start at 0. We're going to end at 360. We're going to step in 30s because I'm stepping in 30s. And now we get some values. Now I work quite fast with this, but you guys don't have to. We're going to start with 0 and 3. We're going to go with 30 and 4, I think, if I'm not mistaken. We're going to go with 60 and 4.73, 60 and 4.73. We're going to go with 90 and 5. And then 120 is going to come back down there. Now, guys, I can almost guarantee you that my graph's not 100% accurate. So please Please bear with me on this part because I'm drawing on a graphic tablet. 180 and 3. Okay, cool. Now 280, 210 should be 2. 210 should be 2. 240 should be 1.27. 270 would be 1. 300 would be 1. Okay, we're going back there. We're going back there. And we're going back there. Now, guys, I'd like you to fully understand this graph. I'd like you to see something quickly that there's no x-intercepts on this graph. There is a y-intercept, but there's completely no x-intercepts. And the amplitude, even though you can't see it, we can have an imaginary. I want you guys to look at this. Even though we can't see the amplitude properly, we can have an imaginary x-axis. It's like an imaginary x-axis. I mean, this wasn't supposed to be there. Guys, please understand this is something I just made up there. That's an imaginary x-axis, and we can see the amplitude of this graph. This grew quite a bit. So this part, it grew a lot. Okay. Now it is bigger than this amplitude. So it is definitely bigger than that amplitude. But now we need to work on this quite simply. Okay. Let's start because the information from this graph is important. But I want you to look at it. The graph got stretched up much more because the amplitude was 2. We can see the amplitude is 2. Excuse me. And we can see, sorry guys, we can see that the graph moved 3 units up. 3 units up. So let's go with the information. Firstly, the domain. The domain is x is the element of real numbers, or x is the element of every number from 0 to 360, because domain is all the x values. The range is y is the element, and that there would be starting at 1, ending at 5, because the lowest is 1, the biggest is 5. The y-intercept we can see on the graph as well. The y-intercept cuts the graph at 0 and 3. The x-intercept, there's none. There's no x-intercepts because we don't touch the x line. Okay. We'll go with the maximum turning point. The maximum turning point, even if we look at our graph, it's 90 and 5. Remember, this is x and y points. And the minimum turning point is technically 270 and 1. Okay. Now, guys, there's stuff that's not here, like amplitude. Now, the amplitude I know is 2. Why do I know it's 2? It's because I take it from the formula. Or I can even count from 3 to 5 because of my imaginary x-axis, or 3 to 1. But we don't have to do that. You can also take the maximum point, which is 5, plus the minimum point, which is 1, and divide. Ooh, the minimum point is not 1. 5, 1 minus 1. Okay, cool. It's fine, guys. This thing is 2. Let me see if it was supposed to be 2. Yeah, it was supposed to be 2. Right, so the amplitude would work on that part. We are gonna have a tiny bit of a problem with certain formulas, so I need to teach you guys something with the amplitude because the max plus min part, right? The graph also shifted. If we look at the shift is 3 units up. And I don't think I left out any information. Let me double check. No. I did not leave out any parts. Y maximum, no. It's cool. So the only thing that I would like you to know is the period is more of grade 11 work, but for now, the period is 360. Just to let you know, there's a formula for period that we can use, and the period is always equal to 360 divided by k. Now, this k value is the number that touches x. Number that touches x, like 2 theta, 3x, 4. So this is just a shortcut that we can use. We'll get to it at a later stage. But again, the amplitude would be 2. The period would be 360, and the shift would be 3 units. And that's all there is to this question. There is a little bit more that needs to be done in terms of k, but I think that's the end of this part. Okay, I just want to clear up quickly that maximum minus minimum divided by 2. 5 minus 1 divided by 2 is 2. I do prefer looking at the graph and looking at the formula, but it can be calculated. The next one we deal with is cos. So when it comes to cos, this is y equals cos theta. We're going to do a really basic graph. Theta is an element of 0 to 360, right? And we're going to start off with the same graph that we did before. Let's put that there. We don't need any of this anymore, right? Basically, we don't need any of this anymore. So we can remove all of this. Right, that's fine. That's fine. And that's fine. Okay, I'm not going to be able to take out this dot because the entire line is going to come out. And here as well. Okay, so guys, the next part we're going to deal with is just the normal cost graph. Quite simple. Same rules. Let's start with mode, table. F of x equals 2. We're going to put it as cos, shift alpha x. So guys, again, mode, table. F of x equals 2 cos x. Close the bracket, guys. It's important. G of x equals to 0. Don't press 0. Just press equal. We're going to start at 0 because they told us to start at 0. We're going to end at 360 because they told us to end at 360. And we're going to step in 30s because your tutor told you to step in 30s. But when your exams start, it's whatever they want you to step in, that's what you step in. Okay? So you guys step in whatever they tell you to step in because your teachers are marking your papers and external people are marking the papers. So it's whatever they want you to step in. If they tell you to step in 45s, you step. If they don't tell you, go for 30s. But most of the time, they will tell you. Let's start. So 0 is at 1. 30 is at 0.86. 60 is at 0.5. 90 is at 0. 120 is at minus 0.5. 150 is at minus 0.86, and 180 is the minimum point. And then cost graphs are good because technically they all mirror each other. You guys will start to see this in exams that they all mirror each other. So we should be good here. If I draw my graph, generally it is a very ugly graph because of my tablet, but this is the best I can do for now, right? I know my points are not touching, but the graph shape is generally like that, guys, right? Okay, so it's generally like that. I can try and remove this and try it a bit neater. But yeah, that's generally what the shape of this graph looks like. And that should be fine. Now, again, this is not perfect. As you guys draw in your book, if you guys are drawing, then you'll see that the shape of the graph is generally, it's quite easy. The graph's turning there. Just remember it's turning there. The graph's also turning there, so don't forget about that turn. And let's start with the information on this graph. We'll start with the basic stuff. Domain. X is the element of 0 and 360. We start with range. Range is y is the element of -1 and 1 because we're starting and lowest is -1, highest is 1. Let's go with x-intercepts. Okay, the x-intercepts we can look on the graph, right? The x-intercepts would be 90 and 0 and 270 and 0. Right? The y-intercept would be where it's touching the y-line, which is 0 and 1. Maximum turning point, we look on the graph as well. The maximum turning points are at 0 and 1 and 0 and 360. Why? Because it's turning there and it's turning there. You don't see it, but the graph does want to continue. But since we restricted it, we said nope. We just cut out there and we just cut out there. We just took this tiny piece in the center. But the graph is turning. So yeah. The minimum turning point would be 180 and -1. Right? The other stuff that we need to know is that the amplitude is 1. As we can do the same formula. Top minus the bottom divided by 2. So it's 1 minus a -1 divided by 2 will give you 1. So max minus 1 divided by 2 will be 1 minus a -1 divided by 2 equals to 1. But even if we didn't know that, we know that the formula is 1 cos x. But that's basically the amplitude, which is 1. There's no shift in this graph. The period of the graph, please understand that normal cos graphs have a period of 360 degrees. So we need to remember that the graph needs to complete like this. This is a full graph. There's sometimes on one Cartesian plane, you might see this. Now we need to understand that cos graphs in general look like that. So if you see something like this, most likely this is more than one graph. You understand? This is more than one graph. So we could see maybe this is 2 graphs, or maybe it's 3 graphs. But again, you'll see a value something like this cos of 2 theta. If you want to know what's the period of the graph, just take 360 and divide it by the number touching theta, which is 180. That would be more of a grade 11 question, but yeah, when you come to the basics, the really, really basic parts, the period of a straight cos graph is just 360. Now, of course, there is A and Q as well in a cos graph, but this is the basics for now. So we're moving on with the next part of this, and we're going to go with the exact same thing. We got y is equal to A times cos theta plus Q. You see A and Q is the exact same thing from before, right? I'm not going to write it down. This is the vertical increase or decrease, how it moves up or down. It's the shift. And this is the increase or decrease in amplitude. Now it's the exact same thing. I'll do it just to sing, but this is the exact same thing. Q, if Q is plus 5, this moves 5 units up. And if the Q is -5, that moves 5 units down. Now, if A is the amplitude, right? And if A is positive, it's the same thing, guys. It's the exact same thing as sine. When A is greater than 0, so if A is a positive, let's say positive 2, what's going to happen is the amplitude looked something like this. Now it's going to look something like that, just as an example. But if A is less than 1, but greater than 0, like a half maybe. So A was like that. Now it's going to look like that, half the size. But the same thing happens with the reverse. When A is less than 0, so like a -2. Example, A is a negative value. This is a reflection because now the graph was looking something like that, right? Now it's going to look something like that. It's reflecting. So what does that mean? When A is less than -1, something like a -2, the graph was looking like that. Now it's looking like that, a little bit bigger. When A is less than 0 but greater than -1, maybe like a -half. So this was looking like that. Now it gets a bit smaller. So remember that negative is a, how do I put it, reflection. It changes the graph around. But again, from the textbook, we do have a picture. Quite simply, let's see if I can get this correct. We do have a picture that's there. And yeah, we should be fine, right? You guys can follow the scale and go with it, but that's for A, that's for Q. Okay, so that's fine. Domain and range, we can deal with it soon. Intercepts, we can deal with it soon. Let's go with a calculation. I think the calculation parts and the drawing of the graph is important. Y equals to 2 cos theta plus 3. Theta is an element of 0 and 360. Okay. Guys, you're going to press mode. You're going to press table. You're going to press 2. Make sure you put this properly in the calculator. 2 cos open bracket x close bracket plus 3. That's when it comes to f of x. So make sure you do that correctly. That's 2. That's cos. That's open bracket shift x close bracket plus 3. G of x, you press equal. Start at 0. End at 360. And step in 30th. And now we're going to get some values that's I'm going to steal from here. No, I should not put this right there. Let's see. Just give me a moment. Let's see if I can just grab this graph. And I managed to do it. Okay, cool. So let's go here and then let's extend the graph a bit. Please mind my line. I understand it's not very straight, but we'll deal with it. Okay, so this line was, yeah, it's okay. That's better than I thought it would be. That's 3. That's 4. That's 5. Okay, cool. Let's start putting in values. Again, I apologize, but yeah, this is as good as I'm going to get it. That's 5. The T is 4.7. 60 is 4. 90 is 3. 120 is 2. 150 is 1.26. 180 is 1 on the dot. And then when it comes to cost graphs, they all have a partner on the left and right hand side below basically half and half. It's very symmetric. So it means it's very simple to plot, but it's also very simple to answer those level 4 questions when you start to understand that all of them have a partner. See 5 in there. If we look at it, there and there, there and there, there and there, they all have partners. So yeah, it's quite simple. It's this one that's left lonely, but it's fine. If we draw this graph, this one is very bad, but I mean, could be worse. Yeah, could be worse, but yeah, this is good as we can get it. Let's start with y equals to 2 cos x plus 3. Okay. Let's start with the information from this graph. We'll start with the stuff that we are supposed to know quite simply. The domain. X is the element of 0 and 360. Range. Y is the element of 1 and 5 because we're starting at 1 and we're ending at 5. Range is all the y values, right? Domain is all the x values. For those of you that don't know, I mean, we started here. That's 1. We ended at 5. That's the range. Now, when it comes to x-intercepts, this one we take from the graph. The x-intercept is none. This doesn't even touch the x line, so there can't be an x-intercept. But the y-intercept is 0 and 5 because I touched the y line at 0 and 5. Now we have maximum turning points, which there's 2. And the maximum turning point is 0 and 5 and 360 and 5. We have a minimum turning point of 180 and 0. I mean 180 and 1, sorry guys. 180 and 1, which is there, there, and there. This is maximum and minimums. Remember this graph was it wants to turn to the next part, but we cut it off. So this counts as the maximum. That counts as the maximum. This is the minimum. Okay? Now, that's fine. Most of this is doable. The period of this graph is 360 because it takes 360 degrees for this graph to finish its cycle, which is there. The period is fine. The amplitude of this graph would be 5 minus 1 divided by 2, which is equal to 2. But we didn't need that because we can see this is 2 cos theta plus q. And this is the amplitude. So this part is the amplitude. Quite simple to deal with, and we should be fine. Now guys, the period is fine, the amplitude is fine. A lot of this we can see the range is okay. A lot of it we can see such a big difference. The graph got moved up by 3 units, right? So this is 1, 2, 3. Everything moved up by 1 unit. Okay, 3 units actually. Sorry, but also the maximum, the minimum points all increased. Every single point in this graph moved up, whether it was 3 units or not. It all moved up. Also, the amplitude means the graph was kind of skinny, was something like this. But now the graph looks something like that. It doubled. I won't say it exactly doubled, but you can see there's a very big difference in the curve. Okay, That's all there is to this part. Right. Guys, the last part of this teaching lesson would be the tan graph. Now, the tan graph is a little bit different. The tan graph is a little bit different, and we should be able to double check, right? So this is quite simple. Let's draw. Okay, let's put this here. Let's see if I can get rid of this part. Let's see if I can get rid of this part, and let's see if I can get rid of this part. Okay. Now, when it comes to a tan graph, you're going to notice there's a few errors that comes up. There's a reason for that error. But I think the best thing to do before we start is just to draw. So let's start. It's the exact same method. We're going to say theta is an element of a 0 and 360. Okay. So what's happening is tan, shift X there. Start at 0, end at 360. Now, the thing is, when it comes to tans, tan steps in 45s. It's very difficult to step in numbers that's not 45. And you can. They give you very weird numbers though. But it's up to you guys. So I'm going to go 45. Let's go 90. Let's go... should I step? Yeah, I should step in 45. So I think you guys just listening 135. I think I went too much. I gave you guys too much of space. Yeah, there is too much of space. I'll have to redraw this graph. Just give me a moment so I can. I spaced it out for 30 years. It should be spaced out for 45s. Okay, that wasn't fun. Okay, so this is 45. That's 90. That would be 135. That would be 180. That would be 225. That would be 270. Then it'll be 315. And that one will be 360. Because if you step in 30s for tan, it's going to cause a lot of problems. Now, automatically, I'm telling you that tan will never exist at 90. And tan will never exist at 270. They don't really teach you this at why in grade 10 and 11. But guys, basically, tan theta is equal to sine theta over cos theta, right? Sine theta over cos theta. Now, guys, whenever we deal with cos, if you deal with cos of 90 or cos of 270, you would see that this gives you 0. Okay? Now it gives you 0. But the fact that it gives you 0 means we have sine theta over 0. And that's undefined. That's why tan does not exist at 90 and 270 is because tan is equal to sine over cos. And this equals to 0. So sine theta over 0 equals to undefined. So tan will always be undefined at 90 and 270. Okay? So let's work with that part. This is the undefined line. I don't know why it's blue, but yeah. It's a broken line, guys, but for now, I'm just going to draw it like this because I'm struggling to draw a broken line. Right, but this is the asymptote, right? Right, so please understand this is a broken line. It was supposed to be a broken line, but uh, my broken line is not looking really good, so I just drew it as a straight line. But this is an asymptote. Okay. When it comes to this graph, it's quite simple. We're going to deal with mode. We're going to deal with mode, table, tan shift x, close there, g of x, start at 0, end at 360, step in 45s, and we deal with it. Now you look at it, and we're going to start off with tan is, that'll be 0. 45 would be 1. 90 is an error, asymptote. 135 would be -1. 180 would be 0 most likely. 225 would be 1. If we start here, error, that's -1. And this should be 0. When we draw the graph, we go there. Let's draw it in a different color. We go there. We go there. Okay, guys, my tan graph is not accurate because it's not curving enough, but let's see if I can get it properly here. Okay, that's the best I can do for now. And then we go there. And guys, there's a few important things. Firstly, the asymptotes is 90 and 270. Tan will never exist at that point. It's impossible. The next part that's important, which we see from the graph, is the x-intercepts are at 0 and 0. The x-intercepts are at 180 and 0 and at 360 and 0. Okay. The y-intercept is only at 0 and 0. Now, that's what we see from here. It's quite simple. The range in the domain is a bit tricky. We need to remember this. The range, we can go with the range as y is the element of real numbers. The proper way to write it would be a y of theta to a y of theta, and you can put it as the element of real numbers. That would be the proper way to write it. The domain is a bit tricky as well. Your teachers might not want this, but you can put x is the element of 0 to 360, but you have to specifically state that x does not equal to 90 and x does not equal to 270. Remember to state those things because it's really important. Or theta, right? It depends on what they give you. Guys, I gave you theta here, but I'm saying x as a general thing. But a theta does not equal to it. Now, the tricky parts that we need to understand is that the tan graph has a period of 180. So understand that the tan graph, the full tan graph, period is how long does it take a tan graph to be complete? It's a year. This is the period. So that's the tan graph period. That's where it stops, right? So the tan graph exists in between the two asymptotes, and that's the full graph. This is more of a half graph. Half graph, this is the period. Of course, the amplitude is 1 because we take it from the formula. But it becomes a bit difficult later on. It becomes really difficult later on because now we do get the values of Q. We know Q is the shift. So if Q is positive, it's moving up. If Q is negative, it's moving down. We know it's the vertical shift, right? That one's easy. The problem is A. Now A is a little bit more difficult to deal with because A has different parts, like the values of A. If A is greater than 0, graphs are going to look a little bit different. Let me go and show you what I mean. Remember that if A is negative, or if A is equal to a negative value, this is a reflection. The graph's gonna flip. And when A is positive, it's normal. There's different parts because the graph stretches differently, but I'm going to give you guys notes, parts that you guys can deal with quite simply. We're going to draw another graph just now, but let's go with some notes, right? I'll try my best to make it neat, but this is from your textbook. Be good for you guys to draw it down, draw it and practice because you don't ever need to draw this, but you do need to understand the shape of it because even if we don't get the drawing 100%, but we understand the shape, when they give you this graph in the exam, you'll understand it because most of the time they will not make you draw in the exam. Okay. Okay. And then yeah. That's the time. We are generally good. That would just be how it was supposed to be neater though. I'm not gonna lie to you. It was supposed to be one table, but yeah, that's the notes. You guys can try and memorize this. It will be good. If you can't, we're in a bit of trouble, but let's go with the next graph, right? So the next graph, it does change a bit. We're going to use the exact same graphs that we've been using for sine, cos, and tan, just to make sure that you guys just see some consistency. But you're going to see there's a big difference. So let's go with 2. Let's go with y equals to 2 tan x plus 1. X is an element of 0 and 360. Okay. X is an element of 0 and 360. I'm trying to make this neat, but it's not doesn't want to work. But okay, cool. So this is 3. That's 4. And that's 5. Of course, our asymptotes are going to increase there. Our asymptotes are going to increase there. It's going to increase there. I'm just extending the graph, guys. Let's go with the exact same formula. We're going to go with 2 tan x close bracket plus 1. We're going to start at 0, end at 360. I'm stepping in 45s, and let's go. I think we're good. I think we can manage this graph. 0 and 1, 45, and 3. 90 is still an error, always an error. Minus 135 and minus 1. 180 and 1, look at that complete skip that's there. And 225 and 3. This goes all the way there. Same thing, 270 is an error. Minus 315, or 315 is minus 1. And 360 is a 1 in general. Now this graph, I could say quite simple. It looks like that. Looks like that. The only one I ever have a problem drawing is you, but let's see if we can get this right. Nope, we completely missed it, but I think with your book, you should get it correct, right? Now, this question, okay, this question is quite simple. The stuff stays the same. Generally, most of it would stay the same. The x-intercepts are, but if you were getting if you're dealing with 30s, we might have got the x-intercept. To be honest, if you're dealing with 30s, maybe, but no. To get this x-intercept, you would have to make y equal to 0 and then solve it. That could work. I mean, technically, you could get the x-intercept by making y equal to 0 and solving it. Let's try. That would be 0. Okay, no. But it's fine. -1/2. Let me double check. I'm just curious. That's -1/2. Shift 10, put that answer there. Plus 180. Okay, cool. So if you wanted this point here, and if you did the x-intercept, most likely it would be like 153 some change, right? But this is not in the grade 10 syllabus as yet, so you don't need to do that. The y-intercepts, I'm going to just ring it. The y-intercept would be here, 0 and 1. X-intercept would be there, 360 and 0, and yeah, 153 most likely. The asymptotes would never change. The period of this graph generally stays the same unless you're going to see like a 2 theta, but it's 180. The range and stuff is a bit difficult to deal with here. I don't know what happened to this part of my graph, but let me just sort this out. Okay, cool. So generally, the range is fine. The domain would be fine. Remember, the range is all the possible x values that could go, because this graph, as much as we're stopping here, it could continue. This one could continue. If we continued, it would just go. So it's all the x values possible. Because this would go very close to 0. Like really, really close, but it'll never touch. But you guys don't need to know that for now. What we do need to know is that the entire y line, or the entire x line, x-axis, technically shifted 1 unit up. That's what it was meant, right? This is an imaginary line that I just drew. So the x-axis shifted 1 unit up, and you can see most points just moved 1 unit up from where it was. But that's all there is to this question. Generally, I think it's quite simple. I don't think there's any problem with tan graphs. I do think it does get difficult when they combine more than one graph together and points of intersection. But there is a grade 10 video on all of the grade 10 level 4 exam questions. That's already on YouTube. So this is fine. We can continue with the grade 11 this thing in the next one.